So we're going to take a look at rational numbers in Chapter 5, Section 3. We want to be able to define them. We want to be able to convert between an improper fraction and mixed numbers. We want to be able to reduce fractions and do arithmetic with fractions, as well as write them as decimals. A rational number is any number that can be written as a fraction. So here we're going to use a divided by b, where a and b are both integers and b cannot be 0, because if the value of b is 0, then your fraction is undefined. The number in the top is called the numerator, and the number in the bottom is called the denominator. We often will use the word ratio when referencing a fraction because in math that refers to a comparison of two quantities. Ratios are typically written as fractions for that reason. So therefore, rational numbers are numbers that can be represented as fractions. So far, the integers we've studied have all been counting numbers. So they've been numbers that you could come up with as you were counting, like 1, 2, 3, and 4. As we look at rational numbers, we have to think about taking those counting numbers and representing them as a fraction. So for example, if I wanted to write the number 3 as a fraction, I would do 3 divided by 1, because if I take 3 and I divide it up, I'm going to get 3. So every rational number can also be written as a decimal because it's going to represent a value between two numbers. When the numerator is a smaller number than the denominator, we call that a proper fraction. So 2 divided by 3. An improper fraction, however, is when the absolute value of the numerator is larger than that of the denominator. This is kind of a math no-no. We don't want to have those as our final answers. So when we're faced with an improper fraction and we can't reduce it any further, we write them as mixed numbers. And a mixed number is mixed. It has a whole number as well as a fraction. And it's important to understand that a mixed number is really the whole number with an addition of the fraction. So if I do negative 11 divided by 2, and I want to write that as a mixed number, I know that 2 goes into 11 5 times with the remainder of 1. So this would be 5 and 1/2, or in this case negative 1, 5 and 1/2. If I want to represent the number 3 and 1/2 as a mixed number, it's important for you to realize that this is really 3 plus 1/2, or 3.5. So let's do some practice with this. If I want to write 17 over 6 as a mixed number, I'm first going to divide 17 by 6. So 6 goes into 17 2 times, and then I'm going to subtract 12 to get my remainder of 5. What I'm going to do with that remainder is I'm going to put it over the previous denominator. So the 2 here is coming from the 2 at the top of the fraction after I did the division, and the 5 is coming from my remainder, and the denominator is because my original problem was 17 over 6. So that's how I obtain the mixed number. Now let's go from a mixed number to an improper fraction. When we do this, there's a bit of a trick to it. So I'm going to take the denominator times the whole number, so 5 times 7, and then you add the numerator. So it's this triangular movement. So 5 times 7 is 35, plus 2 is 37. And then I put it over the denominator that was a part of the mixed number to get 37 over 5. When I'm looking at the sign of a fraction, we typically don't want to put a negative in the numerator or the denominator. We want to put it out front of the fraction so that it indicates that the entire fraction is going to be negative. So not just negative 3 divided by positive 5. The convention is to write the negative out in front. You can reduce a fraction to lowest terms by dividing the numerator and denominator by the same number. So for instance, we have 4/8. I can take the numerator and divide it by 4 and the denominator and divide it by 4, and that's how I reduce the fraction to 1/2. Now when we're teaching students in the classroom, what we often get confused with is we need to make sure we divide the top and the bottom by the exact same number. And that's how we're going to get an equivalent fraction that is reduced. So let's practice reducing these two fractions. So 18 and 24 are both divisible by 2, which gives me 9 over 12. And while I may want to celebrate, oh, I got 9 over 12, I need to realize that 9 and 12 can be divided by 3. So I actually have to reduce this fraction twice. Or if I had divided originally by 9, then that could have got me to the same place. Nothing really jumps out with this example with the numerator. So if we start looking at the factors 8 and 21, I'm thinking that 8 is 4 times 2 and 21 is 3 times 7, but none of those factors have anything in common. So that's how I know that it's already fully reduced, is they have no factors in common that I could divide both the top and the bottom by. Now let's go backwards and write this as a larger fraction. So I can find an equivalent fraction that's going to be larger by thinking of what did I multiply 8 by to get 32? And what did I multiply 4 by to get 56? Because what I do to the top, I have to also do to the bottom. So in the first question, I figure out that 8 times 4 is 32. And since I multiplied the denominator by 4, I have to also multiply the numerator by 4, which gives me 12 at the top to answer my question. And the next one, 5 over 4 goes to something over 56. I figure out that I did 4 times 14, which means I need to do 5 times 14 to get 70. Now, multiplying fractions is one of the easiest operations we can do because you just multiply straight across. So in these examples, I'm going to do 5 times 3 divided by 8 times 5. And when I do that, the 5's are going to cancel out so that I have the reduced fraction of 3 over 8. Now, if your students don't see that the 5's can cancel out, that's perfectly fine. They're going to get 15 over 40, and they need to realize that 15 over 40 reduces by dividing both of them by 5. So you're going to need to feel your students out to see if they can make those cancellations or if they're going to need to just do the multiplication and then reduce the fraction. Here in part B, I do the same process, but the answer is going to be negative. And that's because if you multiply a negative number by a positive number, you're going to get a negative number. This example is a bit trickier because I have some mixed numbers that I'm multiplying. And we don't actually want to multiply mixed numbers. It gets to be very tricky. So we want to convert 1 3/4 and 2 2/5 into improper fractions. So I'm going to do 4 times 1 plus 3, which is 7, over my original denominator, 5 times 2 plus 2 over my original denominator. Now when I multiply this, I get 7 times 12 over 4 times 5, and I can reduce the 12 and the 4 to get 21 over 5. Now this problem has a lot of steps because 21 over 5 is not an acceptable final answer. You're going to need to convert that over to a mixed number. If I want to divide fractions, this is a bit of an interesting case, I need to flip the second number and then multiply. So notice a over b divided by c over d becomes a over b times d over c. So let's see this in action. So I'm going to rewrite the division as multiplication. So I'm going to have 3/4 times, I'm going to leave that negative number in the front. We don't want to mess with that. And I'm going to do times 8 over 5. And then I follow the same steps to multiply straight across that I did with multiplication. In part B, I'm going to see the same behavior. I'm going to need to complete the change from division to multiplication by flipping the second number to get 9 over 4. And then I can multiply straight across. Now adding and subtracting fractions with a common denominator is a little more tricky, and this is probably the concept students will need your help with the most. If there is a common denominator, I just need to add or subtract the numerators. So in this case, I have 5 plus 11, which is 16, and 7 minus 4, which is 3. But if I have different denominators, I have to go through the process of finding the common denominator. And this is a place where students are going to say, why do I need to learn factors? Why do I need to learn multiples? And all those types of things. And the answer is because you need to be able to get a common denominator. So if I want to find each sum or difference here, I'm going to have to find what are the factors of 4 and 6 that will get me to a common number. And if I do 4 times 3, which is 12, and 6 times 2, which is 12, that's going to give me my common denominator. And if you weren't sure how to arrive there, I can do the multiples of 4. So 4, 8, 12. And I counted 3 times, so that's why I know that I multiply 4 by 3. And then I have 6, then 12, which is why I'm going to multiply 6 by 2. Once I have that common denominator, I just add the numerators across, and in this case, I get an improper fraction. So 12 goes into 13 one time with a remainder of 1, which is where that numerator comes from. In the next example, I have 9 and 5. So I'm going to go through the multiples in 9 and 5, and I see that they don't line up until you get to 45. So that means I'm going to multiply 4/9 by 5 and 2/5 by 9. And when I do that, I get 2 over 45, which cannot be further reduced. In part C, I can't do anything with these mixed numbers. I have to convert these mixed numbers over into improper fractions before I can add or subtract them. Now that I get those fractions done, I have 5/2 and 13 over 4. If I multiply 5/2 by 2, that's going to give me 10 over 4, and then I can just add across. Now you'll notice I also get 23 over 4, which is not okay because it's an improper fraction. So 4 goes into 23 5 times with the remainder of 3. You might be familiar with the decimal form of fractions because this is what our calculator tends to give us. We also understand decimals better because they're used with money, and money makes it a little bit easier for us to relate to partial amounts of pieces. So if I'm thinking about these things, place value is incredibly important. And to change from a fraction to a decimal, you would use division. So if I wanted to do 3/4 as a decimal, I would do 3 divided by 4, which is 0.75. So in my place values, I have them lined up here. Notice that in front of the decimal, I have values that are just plural, but behind the decimal, I have the THS. So tenths, hundredths, thousandths, you've got that THS. That's going to be really important as you work with your students to realize the difference in those. So if I want to write 5/8 as a decimal, I do not expect you to necessarily do this by hand. You can just type in your calculator 5 divided by 8. Depending on the age group of your students, you may be showing them long division for the first time, or if you're working with students who are in middle school, you may also want to use the calculator approach. Here's how to write 5/6 as a decimal. So I could do 5 divided by 6 in my calculator, or I could simply complete the division and long division, and eventually I'm going to realize that that is a repeating decimal. So repeating decimals are decimals that continue in perpetuity, and they can be written by placing a line over the portion that repeats. So if you look at the first example, the 3 is the value repeating, so the bar goes over the 3. If you look at the second one, the 6 and the 2 are both repeating, so the bar goes over the top of those. Now, if I want to write a terminating decimal as a fraction, that's a little bit easier because I'm going to drop the decimal and put the place value into the fraction. So if I'm in the tenths place, my denominator is 10. If I'm in the hundredths place, my denominator is 100, and so on. Then I reduce the fraction. So what does this look like? So in all 4 of these, I'm going to drop the decimal, and the place value will tell me my denominator. So this is tens, or tenths, so I'm going to put 8 over 10 and reduce to 4/5. 65, the place value is 100 because it ends the 100th place. So I write it as 65 over 100, which reduces to 13 over 20. Here, my last number is in the thousandths place. So I'm going to put that decimal of 24 over 1,000 and then reduce. So this is the process for being able to go from a fraction into a decimal. Now, what if I have a repeating decimal? So if I have a repeating decimal and I want to take that and multiply both sides of the equation by 10 100, or 1,000, whatever I need to do until I get those repeating digits in front of the decimal. Once I do that, I'm going to subtract them and then divide both sides by the number in front of n. This sounds like a lot of work, but it's not too bad. So I have 0.8 repeating. If I multiply both sides by 10, I just need that whatever's repeating has to be in front of the decimal. And so I get that 10 times n is that repeating decimal. Now I'm going to subtract this to get 9n equals 8. So this would be 8 over 9. Let's try it with a number that repeats with two values. So since I have two values repeating, I'm going to have to multiply by 100 to get both the repeating values in front of the decimal. So this would be 100 times n. I'm then going to subtract 100 minus 1, and I get 99, and then I have the 63 in front of the decimal. So to get to this point, I'm going to do 63 divided by 99. So here's another example where we're going to have a word problem. In her final 2 days preparing for triathlon, Kat hopes to swim, run, and bike a total of 50 miles. She works out at a nearby state park with a swimming quarry and a running bike trail. One lap is a quarter mile, and the trail is 3¼ miles long. How many more miles does she need to cover in the second day? So in order to be able to work with this, I'm going to convert everything over to improper fractions. Then I'm going to use the order of operations and perform the multiplication first before I do anything with the addition. Once I do that, I'm going to subtract 50 so that I can get the distance that she needs to cover on the second day, which is 25 3/4 of miles.